Welcome to our chemistry experiment. In this experiment, we will be testing the effect of catalyst on our chemical reaction. This is hydrogen peroxide. We will be doing the experiment which is called elephant's toothpaste. In this experiment, my friend Abdelaziz Al-Qasmi will pour 50 milliliter of hydrogen peroxide inside the graduated cylinder, and my friend Abdullah Ghulam will pour dish soap inside the graduated cylinder. After that, he will also add potassium iodide. Potassium iodide is the catalyst of this reaction. It is not listed inside the reaction when you are writing it. Pour 50 milliliter of hydrogen peroxide. This is about 15 milliliter of hydrogen peroxide. Now he will pour 5 milliliter of dish soap. That's a good amount. Now we will mix the mixer a little bit. And now we will pour the potassium iodide. When we pour the potassium iodide, it will go up in foam. So once he pours it, we will have to stand back. Go. Stand back. This is the elephant's toothpaste. The reaction that just happened is hydrogen peroxide getting into hydrogen and oxygen. So what's the vapor coming out is water vapor. So H2 and O2. So that's the experiment. Welcome to our chemistry video. As you have seen before, the reaction to H2O2, which is hydrogen peroxide, turned into water vapor and oxygen. As you can see, it was previously as hydrogen peroxide, water vapor and oxygen molecules. So as you can see, it is not balanced, therefore we should balance the equation with two hydrogen peroxide molecules, 2 water vapor molecules and 1 oxygen molecules. So the equation does not actually react instantly as you have seen previously. It needs a catalyst, but as you can see here, there is no catalyst in the reaction section. A catalyst is not written in the equation. It is written on the arrow. Sometimes it is written, sometimes it's not. So a catalyst, which in this case would be potassium iodide, Ki, is written on the line, Ki. And now for the energy graph. This is an exothermic reaction. Previously you saw that the reaction produced heat and smoke, vapor. Therefore it released energy. The reactant started with high energy. This is higher energy. And this is the reaction time, or the process. So at the beginning, the reaction had high energy. The activation energy for the regular reaction would go up, and in the end, where the products are. In the products, as you can see, the energy is less than the reactants. But with a catalyst, the energy graph does not need as much activation energy. It only needs to go less than it. But with the catalyst, the energy graph would not need to go as high as the one before. It would just need to go almost half the way, or not even half the way, since as you can see, when we poured the H2O2 into the graduated cylinder, it did not react instantly. Therefore, the activation energy needed to be higher than the catalyst activation energy. When we poured in the activation energy, the amount of energy required was less than the amount of energy that has already been given. Therefore, the reaction started happening. So in this case, it would not need as much energy required to start the reaction. Thank you very much to Ali Al-Ma'alla for being there all the time, Abdelaziz Al-Qasmi and Abdullah Ghulam for being there with me at the reaction. Unfortunately, they were not able to be here. Thank you very much. And thank you to our teacher, Mr. Muhammad, for advising us with this video project.